My name is Chris Loken. I'm the Chief Technology Officer for an organization called Compute Ontario. I'm going to get into in just a little bit just exactly what that is. I'll talk about what we do, the current landscape of HPC in Ontario, and some of the challenges that we're facing and the opportunities. So just a little bit on my background. So I used to be, I'm a recovering still astrophysicist. I used to do numerical simulations of disrupting radio jets. So this was back in, I was an NCSA user back in the 90s. I was collaborating with radio astronomers at the VLA and with theorists and with one of the pioneers in the astrophysical fluid dynamics field, who's Mike Norman, who's now the UCSD director. And that was great stuff, but eventually I wanted to get back to Canada. All those faculty positions that were supposed to open up, I all heard during my graduate career that 30% of faculty were going to be retiring in a 5 or 10 year period. It never happened. So I fell into running computing systems. So I managed the computing facility of the Canadian Institute for Theoretical Astrophysics. That was back in the days when we could, even less than $1 million Canadian was able to buy a top 40 cluster, which unfortunately doesn't happen any longer. But we had some fun there. And then along came a really interesting opportunity, which was that the University of Toronto got about $30 million worth of funding to build a new system in 2008, 2009. And so I was hired then as the CTO and employee number one of SINET, the SINET HPC consortium at University of Toronto. And I did that for several years, several generations of systems there. Back onto the fun of that. What made that one really fun with the $30 million was that it was pretty much we had no site. So we built our own data center, procured the systems, did the whole thing, got it up and running, built the entire organization. And then about a year ago, I joined Compute Ontario. So what is Compute Ontario? So Compute Ontario is a very new, or is quite a new organization. It was just technically formed in, let's say, 2014, but didn't hire a CEO until 2016, and then I came on board a year later. It's a not-for-profit funded by the province of Ontario because, well, the easy way of putting it might be that they got tired of every university screaming for, that they needed money for their ARC HPC systems, right? And so they wanted to have kind of a what they imagined might be a neutral third party to help advise them on things that were going on in Ontario and then what to do with funding. So Compute Ontario acts as a coordinator and advocate for advanced research computing in the province and for advancing the big data strategy of the province. We're small. It's about a 5.5 FTE organization right now with no plans to grow. And key partners include, we've got five main providers of HPC cycles in Ontario. Some of these organizations have been around for quite a while. I'll say a little bit more about them later on. There's a Center for Advanced Computing. There's something called SharkNet, which SciNet, HPC for Health, and SOCIP. Another role we do is we also represent the provincial coordination or the provincial consortia in discussions and so on with Compute Canada. So Compute Canada is like an umbrella organization for computing across the country, and then what has happened over the years is that we have these regional organizations that have grown up as well. So just a little bit of some quick kind of facts. My rule of thumb generally is that the US is about 10 times Canada, so when we're looking at numbers of supercomputers, numbers of users, all that type of thing, sort of factor of 10 often, since that's the population and the GDP difference ballpark. The interesting thing about Ontario, you may not know, we've got 10 provinces. Ontario is by far the largest. So Ontario accounts for about 40% of Canada by population and GDP. And then inside of Ontario, there's also a large concentration in the city of Toronto, because Toronto itself represents about 44% of the population, 20% of Ontario, 20% of the Canadian GDP, and then these other second largest financial sector in North America, third largest tech sector, and fourth largest city in North America. Whoops, what's going on here? Oh, advance the page, there we go. And yes, that's the type of thing that we see in the papers. So a little bit about the differences between Canada and the US. One of the things that actually drives some of the other things is that funding has been largely driven over the last 15 years at least, by a single organization, which is it's a not-for-profit organization that funds research infrastructure. It's funded by the federal government, and they drive virtually all the research computing funding in the country. And one of the things that's happened out of this is that we really have no mid-tiers of computing. So you can get a grant to buy your workstation, maybe a server in your lab, but if you need anything more, you need to go to the Compute Canada system, so these shared national systems. There's, unlike in the US, where you may have departmental clusters, institutional clusters, state clusters, we don't have that. We go right to sort of the kind of the NSF level, or not the same scale, but that kind of idea. So every university-based PI can get access to the systems. It doesn't necessarily mean they get a lot of cycles. You have to, as usual, apply for allocations to get any sizable amount of time. Though in the past, we have actually been able to, we typically aimed in the past for about 20% of the cycles on all our systems to be used by people who did not actually have an allocation, right? So the small users and the people who are scaling up, the people who are just getting their feet wet, so that they would have plenty of cycles to use. Another thing is that we often use here the term advanced research computing instead of HPC. Partly it's because of this tier thing. We can't necessarily call this HPC because it's representing everything that's above the sort of single workstation level. The other feeling was that HPC was with government often was a little bit of a what's the right word? Sort of an exclusionary term. It was like as if that was something that was a very exclusive domain for certain people. And I've had even researchers say this, right? They say, "Oh no, I don't do HPC." And I go, "Look at them. You're running 10,000 jobs a month on our cluster. I think we can say that you're doing HPC, and you need those type of facilities." But for a lot of them, I think they're thinking of the Hero 20,000 core simulations, that type of thing, as being what HPC is, and then they don't see themselves in any organization that's talking about HPC. So a bit on the Ontario landscape. Users of these the shared systems in Ontario, there's about 800 PIs, so that's the faculty members. On average, they have about 4 postdocs or graduate students that they sponsor, so that gets us up to about 3,000 users in total. Last year, they used about 100,000 core hours, or sorry, not core hours, core years, which I never remember how to convert. I work in core years because that way I understand what fraction of the system we're talking about when somebody wants some number. I can't do the other division in my head quickly enough. The usual suspects: climate, this astrophysics, high energy physics, aerospace, all those are the usual suspects, along with a bunch of, with social sciences growing as well in there. Across the province, we've got about 70 expert HPC/ARC people across those 4 or 5 sites. They operate the system, support the users, act as facilitators. They do the whole 9 yards. And we have significant training efforts. This was something that was discussed a lot yesterday for graduate students, researchers, postdocs at the universities, because they don't learn programming, right? And they don't learn numerical science type stuff. So we have found that's to be just a huge and growing field, especially once we started reaching out to the non-traditional science people. So this slide makes that point. This is just at one of our consortia, the growth of the number of person hours of training delivered every year. So up to 8,000 estimated for this year. So that represents, if there were 200 people who took training, that would be 40 hours apiece for that. So there's a lot going on just from that one institution, which is University of Toronto. But the red shows the growth in the data science part of the curriculum. We started at SciNet teaching, MPI and OpenMP, and that was about it. And then once we started branching out into, Python and R and neural nets, so all that type of stuff, then huge increase in the number of people who wanted to take courses or take our classes. Another way of looking at the landscape a little bit here is these are the Ontario Top 500 rankings over about the last five years. It's about 15 systems that made it onto the list. And I had the ones that I put on in the heavy lines are the ones I had the fun to be working on. So that was, this one here, back in 2003 or 2002, was just a 512 core commodity cluster. We bought it from some no-name vendor who went out of business 6 months later, but it was fine. We got a good deal, and we built a hypercube and a 2D mesh out of commodity GigE switches, and it actually did reasonably well. It was, and like I said, you get there, number 38 in the world with $900,000 Canadian in 2002. Then I talked about that $30 million of funding we got at Cynet. We put in a Power 6 system that was in our tightly coupled capability system for the climate modelers, and we put in a general purpose cluster there, which was, we hit a sweet spot, so that was the largest Nehalem cluster. Nehalem had just GA'd. We delayed our procurement for exactly that reason, and that cluster was for a long time also IBM's reference cluster for the size to which GPFS was known to scale, because you'll see in the red books for years there was we know it works at up to 3,804 nodes. That system, we did an upgrade here that bumped it up, gave it a 55% boost in the RMax, or the RMax, which was just because we changed our networking to be InfiniBand. At the beginning, we only did a quarter of it InfiniBand to save money, and the rest GigE, because we knew there were a ton of users who really weren't going to notice the difference. But the upgrade there gave us a big advantage. Then there's really a gap in funding. This one here is a new system that's been installed. This guy here, 67, came from a different funding source, and so this is, I'll mention this later as well. This is an academic industry partnership, and so what we ended up doing was getting federal development money, and we installed a BlueGene Q, which was the one and only BlueGene system that's ever made it to Canada. This one here is the, whoops, oh jeez, that's, oops, sorry. This is this one here, 55, is a guesstimate. This is a system that just went into production last week, which beginning of the month, which I'll talk about a little bit later. We're guessing it will be a 42 on the previous list, but it's probably coming in as a 50 or 55. So we're finally getting new systems. Again, I'm going to talk about this a little bit later, the problems of funding. So we had a long drought with no new systems. In Ontario, just in the last year, there's been a 35,000 Broadwell core system installed at the University of Waterloo. That's got about 320 GPUs in it, and interestingly enough, that's a vendor that probably doesn't sell an awful lot in the US, certainly not at DoD or DOE labs. And then the Niagara system at University of Toronto, which is 60,000 Skylake cores, and has a couple of other neat features like the Mellanox EDR Dragonfly Plus topology with the ConnectX-5 and an Accelero burst buffer, and we're still waiting to see exactly how well that, or how that's going to be used. A few notes on a couple of the interesting sites in Ontario, or the more, well, I consider to be slightly more interesting. Cynet, we built an off-campus data center on purpose for HPC that's not shared. Like many university computing centers are shared, you know, like there's the enterprise stuff in there, there's other departments in there, and then there's maybe a big research system. This one is devoted to HPC, 4 megawatt power feed. PUE was a big concern at the beginning, so when we built it, we actually put that into the RFP. We had a cap on operating costs. We had a cap on the PUE actually measured over 5 years, and IBM delivered on that. They won a large contract there. So water cooled, rear doors, all that type of stuff, cooling tower, and drove the PUE down to 1.18. That also means not an awful lot of redundancy when you've got that kind of PUE and you're doing it cheap. All right. HPC for Health, one of our partner consortia. This has been a really interesting undertaking. If you're familiar with the hospitals and concerns about privacy and all that, it's very difficult to get hospitals to share. So these are the 2 largest research hospitals in Canada. They're about within 200 meters of my office. They're close, they're right beside each other. And they finally, a few years ago, agreed that they could put each of them put equipment into one system and run it as a cloud, and actually be able to burst into each other's sections. So that's a multi-tenancy, elastic, secure cloud, and they have more and more groups joining in there. So you buy some nodes, you add them in, you agree to give up 20% of them or something for everybody else, and then they've managed to get all the privacy concerns taken care of, basically by, well, the two groups, or the tenants cannot share a node. That's the problem they ran into, right? So if, as long as they were able to convince the auditors and the privacy people that the two hospitals would never share a single node and they would never actually share the same scheduler instance, then it was fine. So they had to do some sort of meta scheduling on top of that. The other interesting group is SOCIP. So this is pretty unique because it's a consortium of Ontario universities that got together originally with IBM and created this, or what they did was they bought equipment and then they made it available to academic industry partnerships. So they had the Blue Gene Q, they had a large memory system, FPGAs, GPUs, and have actually developed a lot of industry academic partnerships. Then I was going to say a little bit about some of the Ontario science, or Ontario-related science. This thing here actually sits in BC, but it's driven largely by, or key people in it are at the University of Toronto. So CHIME is the Canadian Hydrogen Intensity Mapping Experiment. We had a discussion yesterday about how the universe was decelerating and then started accelerating at some point in the past. That's one of the key targets of this thing, is trying to understand what happened during that epoch when we switched from deceleration to acceleration. It's going to look for neutral hydrogen in a large chunk of the universe. This is a radio telescope that just looks like a bunch of skateboard half pipes, right? Doesn't move, doesn't need to do anything. But it's got tremendous it's got tremendous compute requirements even right there on site, right? Because you got to convert analog signals, analog electronic signals into digital format. You've got to do correlations on them. That all has to be done on site, has to be done in Faraday cages because you can't have any interference with your experiment. And they have some crazy 7 peta operations worth of compute packed into a couple of small trailers there, because they've got GPUs, FPGAs, and x86 in order to take care of all those requirements. And then once they've got their data, then they ship it off to the HPC centers for further analysis. I realized this morning that I had forgotten a slide, which is kind of embarrassing to drop out. I was going to mention Snow Lab. So maybe one of the crowning jewels in Canadian science has been the Sudbury Neutrino Observatory. So they built a detector, filled it with heavy water, stuck it 2 kilometers underground in an old nickel mine in northern Ontario, and that got Art MacDonald at Queen's University to be a co-winner of the Nobel Physics Prize about 2-3 years ago for the discovery of neutrino oscillations. And that lab, by the way, is actually continuing to be, they're not doing that experiment anymore, but 2 kilometers underground, it's an ideal place to do a lot of like dark matter searches and different types of physics where you want to get rid of the messy cosmic rays and all the other background. And even NSF is funding projects in that mine. So some of the challenges we've faced. Funding model. It all comes back to the funding model. So when we buy a computer from one of these national shared systems, the feds pay 50%, the province that's lucky enough to host it has to pay 50%. And then when it comes to operating costs, the feds pay 40%, and the 60% comes from the province one way or the other. And usually what that works out is 20% from the institution and 40% from the province. So the thing is, guess who sets the rules? The feds, because they're the ones that drive this whole process. They're putting in less than half the money for the capital and operating, but they want the full say on how things are set up and run and done. And there's a big question about what do the institutions get. I've had to meet many times with the U of T senior administrators and go, let me understand this. They're saying, we pay about $1 million a year in operating costs for this system and we get nothing out of it. Our PIs have to go and apply just like everybody else, get reviewed like everybody else, and say, yep, that's the way it works. You get the reflected glory of having a site. That's about it. Furthermore, the capital and operating that we get are separate grants, and the timing isn't even aligned. So we buy new systems, and anyway, it's been very challenging.
funding has been unpredictable. 8+ years between the last two funding rounds. We're putting in systems now. The last funding, we had a funding round in 2006. The next one was 2015. We all thought it was going to be 3 to 5 years before we got the next round, and it was almost like the funding agency was going, "We just bought you a computer. Why do you need another one in 10 years?" So this shows actually, so this is something we do often. We're trying to compare, trying to make arguments about what we need for funding levels in Canada. So I just take top 500 stats and take the our peak or our max, it doesn't really matter, add them up by country in the academic sector, divide by the GDP, so you can normalize these things and then see how Canada's been doing. The heavy purple line is Canada, and you see this jagged stuff here. So that was that last round, or here was the last round of funding in sort of 2000. It was announced in 2006, kicked in here, got us up on sort of onto track again, then dropped off, and now we got this new one. Similar thing happened down here. So it's this sawtooth kind of thing. You go years between funding, and you can't do any real planning for systems. But it's not just that. We're also low compared to the rest of the G8. So that's the other countries I'm showing here. It's difficult to compare against the U.S. because the U.S. is always sort of going to be the monster in the room. But when you take it, we have more traction arguing with the government when we can talk about France, Germany, United Kingdom, and how we compare with them. And typically we're sort of at like about, on average, maybe about the third of the funding level in terms of, the funding level, in terms of if that's a proxy for if the R max divided by GDP is a proxy for that. Other big challenges, as with everybody, power costs. It's among the highest in Canada, in Ontario, and this hurts us because when there are competitions for where to run a site, everybody wants to look at the operating costs, and if you're in Ontario and it costs more, then that does not help you. Quebec has a power rate which is less than half of what it is for in Ontario. We've been paying lately about 14 cents a kilowatt hour, and that has risen by a factor of 2 since I started. When we first installed our system, we were paying about 7.5 cents. It's now 14 cents. So now that's the downside. It's among the highest in Canada. I suppose part of the reason that the rates are high is because we did some good things, which was it was the first big jurisdiction in North America to get rid of coal in power generation, and now 14% of the power is from renewables. The guy who owns the building that we're leasing our space in put solar panels on the roof. He gets 70 cents a kilowatt hour for 20 years. So someone's making up the someone's compensating for that in the system, and that's us. It gave us a great incentive though to lower the PUE. So we were very concerned about that when we first installed at Sinet. That was why we pushed for that PUE of 1.16. We've measured, because we didn't actually hit quite the loads that we'd expected. We've measured at 1.18. And then there have been some recent rule changes that are helping us. So the Sinet power rate has now dropped about 25%, just because the government changed the classification fairly recently. Or not the government, the electric, what is it called? The electrical system operator. But they have also a very kind of strange thing in here, which we may benefit from, is that when they calculate the price you pay for electricity in this new category we're in, a key factor is what fraction of the total draw in the province was due to you in the 5 peak hours of the year before. So if you actually know those magic 5 hours in the year when you hit peak demand in the province, if you can cut your load to 0 for those 5 hours, you cut 60% off your power bill for the entire next year. So, which is of course exactly why they're doing it, because they're trying to drive industry to lower peaks and to make sure that they're not, they're trying to drive the provincial peaks down so that we don't have brownouts, blackouts, whatever. But it remains to be seen how well that's going to work out for us. Good opportunities for some clever programming, maybe even machine learning type stuff, in order to try to predict this and try to reduce our power bills. So far, we've seen about a 25% reduction because of the changes. Some of the opportunities, those were challenges. 2 of the things that Compute Ontario is doing. So this is the luxury now of having a provincial organization where you can actually spend some time thinking about and doing things. Before, In my previous job, you know, it was run the site, keep the systems running, keep the users happy, and then if you had a little bit of time, you could do things like think about where the province should be going. Now we can do that. Now we can do that full time. So we're working on an HQP strategy. This is another Canadian term. Highly qualified personnel is what we refer to. So these are the people who are the ARC experts who are running systems, and also the people who are becoming experts in using advanced research computing. And so we're looking at qualifications, training, retention, skill gaps, all that type of thing. We also have a technology investment strategy that we're working on. This is something that Hyperion is helping us with right now. Identifying researcher needs, future trends, trying ultimately to set some target investment levels and areas for the province. And we need this because we need to have something sort of solid to give the province about how much they should be funding us. Another big opportunity that's coming up, of course, everywhere is AI. Toronto has been a bit of a hub for that in Canada. The Vector Institute was created last year, virtually out of the blue. We didn't know this thing was coming along. Well, we had about a month's hint that something was happening, and suddenly they'd locked down $150 million in funding, $100 million from the provincial and federal governments, and $80 million from industry. It helps when your chief science advisor is Jeffrey Hinton, so that certainly did not hurt. Uber has put their first self-driving lab outside of the U.S. in Toronto. In fact, both those, Vector, Uber, Compute Ontario, Synat, we're all in the same building, the same innovation hub right downtown. Sorry, I thought I was going to make another point about the Vector. Well, this has led to some of the first tangible results, I hope, for Compute Ontario, which is that we're working now closely with Vector, HPC for Health, and the Orion Research Network in order to lock down some more funding to do a really interesting AI project in health. So Ontario, single payer, we've got longitudinal health data for at least 30 years on 14 million people. There's like a ton of data, and no one's actually been able to apply any machine learning stuff to it. But we've got HPC for Health, where we've got HPC equipment, and we've got all the privacy concerns and all that type of stuff locked down. So now it's essentially, it's easy. Buy some GPUs, use the Vector experts, and start doing something interesting there. Oops. So, what do I have for conclusions here? Yes, so the good news is that we're in an exciting period for two reasons. One is that we're just having our large systems refresh. There's a total of $100 million across the country. I didn't talk about this earlier, but there's been 5 large systems, well, sorry, four systems installed, 1 to go. So there'll be a total of 5 systems in about a year and a half, kind of a 2-year period being installed. 200,000 cores total about between those systems. We've still got one procurement that's underway, so we don't know what the final number is going to be. But the other thing that's exciting is that the federal government has signaled that there may be some big changes. So the budget, which was just released a couple of months ago, had told, or a month ago or so, told us that we're going to get like $572 million over 5 years for digital research infrastructure. But as usual, we don't know exactly what counts as digital research infrastructure. So, you know, if they've got some AI or big networking things in their plans, we're not sure. But we're hoping that an awful lot of that is for ARC or high HPC and research data management. They've also signaled that there may be some changes that are going to get us sustainable funding again. So we're basically hoping to become more or less a line item in the federal budget and get 5-year tranches of funding and know what you're getting ahead of time. So the National Networking Organization gets funded this way. They get 5 years of funding, and they often are able to get their next 5 years of funding locked down 2 years or, well, a year before their funding expires, right? So you can actually plan and do things. And with the things like what I talked about with health, Compute Ontario now is getting its legs, new organization, but we're starting to show some positive results for researchers. All right, thanks.
Thanks very much for that really interesting presentation. A friend of mine, Alex Ryan, is the program director for the Mars Solution Lab in Toronto.
Okay. That's where our offices are.
So I was wondering, if there's any work going on to try to understand how these research capabilities may be amenable to help address not necessarily just sort of scientific and high-end problems, but sort of very complex, large-scale community and policy problems.
Well, I'd say the health project I talked about, that's the first step on that, because that's the whole reason. The goal is to set up this. One of the first projects is what they're calling a risk dashboard. It's trying to identify the high-cost users of the health system. So I can't remember the number now. It's like 80% of the cost of the health system goes to 10% or less of people, right? There's a huge, so if you can identify those really, the really high cost users early, there may be ways of improving outcomes and cost benefits. So we're starting with it. This is where the machine learning is coming in, and we're selling it to the government as being the first chance to start doing something with, well, community data. It's interesting, the chief coroner came to us, came to Compute Ontario, because he's interested in this as well. So the coroner, interestingly enough, if anybody dies under suspicious conditions, he can access all the data that the province has on them: medical, health, education, employment records, all that type of stuff. So if you can get a hold of that data, even though it's a subset of people, the ones who have died under potentially suspicious circumstances, it may actually have a big public policy kind of impact. And so, yeah, so that's another exciting one too. And that also is going to play off this health. We're calling it the health and artificial intelligence data analysis platform. I can't remember, but yeah. So that will those are definitely things that are underway. And that'll lead hopefully into more. If we can just demonstrate success with that, the province is going to be really, really interested. As with everywhere, health is a huge piece of the provincial budget, right? It's like order 40% of the budget. So anything they can, for them, these $50 million in systems is chump change. But right.